Okay, students, we completed the first part in electrochemistry. Okay, now see the second part. Now we're going to study about the electrolyte. Okay, so the electrolyte. What is electrolyte? Any salt must give what? When dissolved in water, it must give what? Ions, no? It must give ions. That's called what? Electrolyte. Any salt, when it dissolved in water, it must give ions. It's called electrolyte. Okay, now we are going to study with the conductance, how the electrolyte will conduct electricity. Okay, what are the necessary conditions? Okay, this is all we are going to study. So every conductance we have some resistance will be there. Okay, so how much solutions we are taking. So the resistance depends upon length of the solution and area of the cross section of the solution. Understood? So we have some relations will be there. So what's the relation means? R nothing but what? Resistance of the electrolytic solution is directly proportional to length of the solution and inversely proportional to area of cross section. Okay, the length of the solution increases, you know that. Suppose it's a, here we have solutions will be there. Okay, the length of the solution increases, resistance also increases, but the area of cross section will be, these two are inversely proportional. So based upon this, we are going to have some small derivations. R is equal to rho into. Okay, what is rho? Rho is called specific resistance. Okay, therefore rho is equal to what? RA by L. This unit is very, very important. R means ohm, no? Ohm. A is not, suppose if it is measured in centimeters, meter, length is measured in centimeter, means this will be what? Centimeter square. Are you following? Length is measured in, length of the solution is measured in centimeter, means it is centimeter, means this is area of cross section, it will be centimeter square. So what? Cancel this one, no? Ohm centimeter, or we can say meter, anyhow. Okay, so rho specific resistance is, that's a unit of, therefore what? Unit of rho is equal to ohm centimeter. Okay, that's actually this is one formula, just keep in mind, this is one formula. Okay, then resistance will be given, area of cross section will be given, L they'll give. Okay, this one formula. Next one, conductance and resistance are inversely proportional, no? Are you following now? Conductance and resistance are inversely proportional. If you have more resistance, conductivity will be what? Less. Understood? Correct or not? Okay. So likewise here, but in your book, instead of C, they put G. G is called conductance. That's the difference. Okay. So conductance and resistance are inversely proportional. Likewise here, I am saying kappa. Kappa is called specific conductance, is inversely proportional to specific resistance. This is called resistance. This is called specific resistance. This is called conductance. This is called what? Specific conductance. Or we can say specific conductance. Both the names you must know. Or we can say what? Conductivity. This is nothing but what? What? Specific resistance, or we can say what? Resistivity. Both the name must know. Okay. So kappa is equal to what? 1 by rho. What is rho? Rho we already know, no? What is rho? RA by L, no? So it will be what? L by RA. Can you write like this? So how to write this? 1 by R, L by A. Can you split like this? Okay. Then kappa is equal to, L by A nothing but cell constant. The cell in which length of the solution and area of cross section will be solution will be constant. The L by A only we can say is called cell constant. Then R is called resistance. Okay, this is a formula, keep in mind this. Okay, based upon they will ask some question. Okay, specific conductance or conductivity is equal to cell constant by resistance. Okay, then what is the unit of kappa? Unit of rho we know. What is unit of rho? Ohm centimeter, no? Kappa and rho are inversely proportional, no? So this will be what? Ohm inverse, correct or not? Opposite, no. Kappa is equal to 1 by rho. Rho we know. Understand? Ohm inverse nothing but what? Mho. In other words, we can write mho, no? Centimeter inverse. Mho nothing but Zeeman. Zeeman we can say. It's called Zeeman constant. Instead of this, we can use Zeeman. So S is a unit for that. Very, very important. Keep in mind. So unit of kappa is equal to Siemens centimeter inverse, or we can say Siemens meter inverse. Both are same. Okay. If you measure in centimeter, we can use centimeter inverse. If you measure in meter, we can use meter inverse. Okay. Right. Just keep a general right. Okay. This is one formula. This is another formula. This is the formula. Just keep study as it is. Then okay. Next one is, what is the unit of cell constant? All the unit keep in mind. What is unit of cell constant? What is unit of cell constant? Cell constant formula is what? What is the formula for cell constant? L by A, you know. This is centimeter means what? This is centimeter square. So what? This is unit for centimeter square or centimeter inverse or meter inverse, we can say. Okay. Memorize the formula based upon any questions coming means you can be able to answer all this. Okay. Okay, right. All this information just write. Rho is called resistivity, kappa is called conductivity. Understood? Then another formula, another term I'm going to introduce, that's called molar conductivity. Finished all this? Okay. Next one is, molar conductivity. You just write specific conductance and molar conductance. Specific conductance and molar conductance. This is symbol is, kappa, no? Correct or not? This symbol is called lambda. Okay. Definition is study, conductance of the solution depends upon one unit volume of the solution. Suppose here, what is this? It's a, it is a cell, the cell in which we have two platinum electrode is there. Okay, two platinum electrodes. Here we have electrolyte will be there. Okay, understood. So it's a platinum electrode. Okay, suppose here in this area, suppose here, conductance of the solution containing one unit volume of the solution. In between, how many ions are coming? In between, how many ions are present? Okay, conductance depends upon number of ions. No, if you have more number of ions, more conductance taking place. Understood? The following, if you have sodium ion, chloride ion, more number of sodium ion, chloride ion present means the conductivity will be more. You know that. Okay. Suppose here, likewise, in between, how many ions are present? So based on, we have conductivity increases. So specific conductance depends upon, conductance depends upon one unit volume of the solution. Okay. Then molar conductance is nothing but, it depends upon conductance of the solution containing 1 mole of the electrolyte. 1 mole. 1 mole means, suppose for example, 1 mole of sodium chloride means what? 58.5 gram in 1 liter of water. Are you following? That's called 1 mole of the electrolyte. You take, why I am taking 58.5 gram? Sodium 23 gram, chlorine 35.5 gram. So totally what? You take 58.5 gram and put it in 1 liter of water. That is, we call it as 1 mole of sodium chloride. That conduct, sodium chloride is electrolyte. That conduct how much electric current, how much conductivity. That's called what? Molar conductance. Okay. So here specifically we should mention, in between how many ions are there? In between the two electrode, how many ions are there? So that's called specific conductance. Okay. Then this is definition. Just you study. It's given very clear in textbook. This point only you keep in mind. Second point, on dilution, we are adding water. What happened? On dilution, what happened? Suppose, for example, here 10 ions are there in between. On dilution, splitted. The ions are splitted. On dilution, number of ions decreases, no? Number of ions decreases. Therefore, kappa is also what? Decreases. Okay, understood? And I told you, generally, number of ions increases, conductivity also increases. But on dilution, number of ions decreases between the two electrodes. So conductivity also decreases. Okay, now come to right hand side. On dilution, this point only just write, all of you. On dilution, first point only definition. This is nothing, only definition. On dilution, what happened? On dilution, see, we have one formula is there. Lambda m is equal to kappa into V. Just keep in mind. On dilution means what happened to the volume? On dilution, volume increases, no? On dilution means we are adding water, no. Volume increase means what? Lambda m is also increase. On dilution, volume increases. Are you following? Therefore, lambda m is also increases. This very important. Just note down. Second point only theoretical point. Okay. Then this one I told you. What is the specific conductivity formula? I already given. Once again I will write it here. Cell constant by resistance. I already given. Once again write. Okay. It's a formula. What is the unit for that? Siemens centimeter inverse or Siemens meter inverse. Are you following? What's the formula? Lambda m is equal to kappa into 1000 by C. Here formula is, unit is Siemens centimeter square mole inverse. Just very, very important formula. What is kappa? Kappa they will give, substitute here. C nothing but concentration. If you substitute means you can get answer. Suppose if kappa in centimeter means use this formula. If kappa in meter means use this another formula. If 1000 you put denominator. That's all. Simply keep in mind. Okay. Another formula. Siemens meter square mole inverse. Understood? Just okay. There is a difference. Are you following? Centimeter means use this formula. Meter means use this formula. That's all. Simple. Mostly they are asking only centimeter. Mostly. Understood? Written everything? Okay, right. New unit for this. Okay. Just write one question because without problem, no NEET examination, no. So write one problem. It's simply I'll write kappa. Kappa is equal to book question itself. I think 0.12, 0.248. 248. Siemens meter centimeter inverse. Okay. Concentration nothing but is given 0.20 molarity. Okay. Find out lambda. Simple. Write fast. You write Q. Q means question. Problem. Understood? Just substitute here. What is this? Centimeter? No. So use this formula. Okay, use this formula. Kappa into 1000 by C. Use this formula. Very important formula. Read fast. So what is this? How to solve this? lambda m is equal to, use this formula kappa into 1000 by C. So kappa is given, 0.0248 into 1000 by C is called 0.20. Okay. Understood? Written? Oh, okay, simple. That's all. What happened? When you multiply, this will come here, no? This comes here, no? Here. This will come here, no? So product 24.8 by again multiply by 10. Again multiply by 10. So 248 by 2. So 124. What's the unit? Centimeter, no. Siemens centimeter square mole inverse. Right fast. List out the formula. Only we have few formulas will be there. Centimeter square. Why? Then because here C here, no. This is what? Siemens. Kata. C is called concentration, no. It's called mole per centimeter cube. Mole per, no. When it goes to numerator, understood? Are you following? Actually, centimeter inverse by mole per centimeter cube. So when it goes numerator, what happened? It becomes what? Siemens centimeter inverse. Only 3 though. It goes numerator, but it is denominator, no. Then it goes numerator. Okay, by mole, no. Mole, correct only, correct. Mole. So what? Cancel. 3 minus 1? 2 only. So Siemens centimeter square mole inverse. That's a unit for that. Cut off. Finished? Okay, simple sum. Very simple sum. Okay. Then next one is, suppose here, now I'm going to start, Kohlreich law. What is Kohlreich law? Study, Kohlreich law. Electrolyte conduct electricity means, electrolyte producing what? It's electrolyte. When dissolved in water, it produces Na plus and so cation also produce, anion also is producing, So sum of the conductivity of cation and anion. Okay, that's why it's called Kohlreich law. If you want to find out the conductivity of sodium chloride depends upon what? Sum of the conductivity of cation and anion. It's called Kohlreich law. Simply remember, okay. So here simply I am writing lambda m naught of NaCl what? Nothing but lambda m naught of plus lambda m naught of what? Lambda m of Cl minus. It's a univalent electrolyte. Simply we can split. Okay. All the values they will give. Sodium ion, chloride value give. You add this. If you put here, then you can. If you add this, we can get this. Lambda m naught sodium we can get. Univalent, simple, very simple. But bivalent. See, lambda m naught of calcium chloride. This is called, sometimes they ask, this is called 1:1 electrolyte. Valency, both are having valency 1, no? But this is valency 2. 2:1 electrolyte. This also keep in mind. Okay, 2 is one electrolyte. Okay, how to split? Lambda m naught, lambda m of Ca2 plus 2 times, it is very important, 2 times lambda Cl minus. They will give the value. They will give value. Suppose here, for example, lambda m of Ca2 plus, for example, I am saying 2. Lambda m of Cl minus is equal to 3. Understood? So we can substitute, no? Also 2 plus 2 into, the 2 into is very important. Okay, 2 into, okay, what? 3. So what? 2 plus 6 equal to 8. Likewise, aluminum chloride, tell me. The splitting is very important. Lambda m of Al 3 plus. What kind of electrolyte this is? It's valency 3, no? So 3 is to 1 electrolyte. It's also 1 mark answer. Understood? Tell me. Plus? The 3 into. The 3 into is very, very important. Understood? Lambda m naught of m of Cl minus. So, suppose, I'm saying this is, Al3 plus is, I'm saying 4. So what? Chlorine already I have given. So what? 4 plus 3 into 3. Understood? So 4 plus, understood? Like this, okay? Very simple. Now this one, they are very important. You tell me, Al2SO4 thrice. These are all strong electrolyte. When you put in water, completely ionized. It is producing conductivity easily. Okay? So everyone split into ions. So each and cation and anions producing some conductivity, no? So if you add the sum of the conductivity contributed by cation and anion is called Coleridge law. Okay? Both are responsible for conductivity, no? Both are responsible for conductivity. It's called Coleridge law. Okay? Right. Split down. Be quick. How to split? Al means you must know what is the valency of Al? 3. Al 3 plus. How many times? 2 times. So what? Lambda 2 times Al 3 plus. Understood? Plus how many times? 3 times. So 3 times lambda not of SO4 2 minus. Understood? Simple. After that you can put the value. Simple. Okay. Understood? So 2 into, I given, no, what is that? 4. Some values I'll give, okay. 3 into, suppose SO4, SO4 2 minus, so we can say 7, anyone values. 7, so what? 8 plus 21, that's all. So okay, just note down, this one is very important. The aluminum sulfate only, they are asking mostly, because no one can able to split. What kind of electrolyte? Its valency 3, no? Its valency 2. 3 is to 2 type of electrolyte. That also important. Keep in mind. Write first. They'll give the value. You must know how to split. That's all. This only just keep in mind. Understood? Write fast. These are all strong electrolyte. So when you put in water, everyone split into ions. Completely dissociation takes place. That's why it's called strong electrolyte. Okay. Next. Right. Suppose for weak electrolyte, if you put in water, it will not completely dissociated. Mostly organic substances are weak electrolyte. So it will not split it means, then only how will you find out the conductivity means, we have one idea. So what idea they are using means, suppose for example, you just write, put on heading, lambda m for what? Weak electrolyte. Weak electrolyte. Okay. Now, for here, you know that for example, acetic acid, best example, acetic acid. Okay, it is not splitted. When you put in water, it is not splitted into, it is not splitted into what? CS3, CO minus plus. Actually, it should be splitted like this, but it will not split. Okay, so then only we are following. If you want to find out the lambda m of acetic acid, we are finding its salt. Instead of this, we are finding some other thing. Okay, its salt we are finding. Okay, its salt means what? Its salt we are finding. So lambda m of its salt is what? Instead of H you put Na. So CH3 CONA. Its salt we are finding. Plus, tell me. It's a weak acid, no? It's a weak acid, correct or not? So you find out, you put one strong acid. Strong acid means what? Correct. It's a weak acid, you should take strong acid. If a weak base, strong base. It's a clue. Minus. If you add together, what's the salt? What kind of salt will be formed? That means you have subtract. Lambda m of what? NaCl. Okay. This is the formula for. If you find out, it's a formula. If you find out these, it's a lot of electrolyte. When you put in water, it completely ionized. So you find out the lambda m of this salt, HCl, NaCl. Then if you add together, then you find it separately. Then you put the value here. Then only that value is equal to lambda m of acetic acid. They are saying. Or we can say lambda m of acetic acid means this formula only keep in mind. Don't worry about the other one. Okay. So if you can split, how to split this one? Minus plus, Na plus, no? Plus, tell me. Lambda m of H plus, lambda of Cl minus, lambda m of Na plus, minus, no? This minus is common for both. Correct? Minus Cl minus. Okay. Now, if any similar means you can able to cancel, no? Plus Na plus, this is minus. Okay. This is plus minus. Now, who is remaining? Who is remaining? Lambda of CH3, CO minus plus. This only remain, no? That's equal to this one. Okay. Don't worry about the other one. This one is just study the memory, is the formula. Just this only write. They will give the value. This value they will give, this value they will give, this value they will give. Just subtract, that's all. Write fast. This for weak electrolyte. One more formula I will give. This is acid. I given acid, no? So I given on base. Just write formula. Base means NH4OH. Weak base, no. Strong base I am taking. NaOH minus right. Another formula. These two formula only keep in mind. Okay. They'll give the value. This value, this value, this value. This. Sometimes this value they'll give. Understood? They'll ask to find out this one among these three, any one. Sum is there based upon, textbook on sum is there. You go through. Finished? Okay, right. Get fast. Formula, these two formulas only keep in mind. Solve. This is for weak acid, this is called weak base. Okay. Weak acid we cannot find out. Then only we are finding in this way. If you find out this electrolyte, that will be equal to lambda m naught of CCCOH. Okay. This is for weak base. Okay. Right. Another one. Okay. Next one is another small term is called limiting molar conductivity. Limiting, we studied limiting molar conductivity means what? Lambda m naught. It's called lambda m naught. Okay. So what's the meaning for means your molar conductivity is measured at infinite dilution. Infinite dilution. This is for only suitable for weak electrolyte. So molar conductivity is measured at infinite dilution. That's the meaning for that term. Molar conductivity is measured at infinite dilution. Infinite dilution. That's the meaning for that. Okay. Suppose for strong electrolyte, weak electrolyte. Okay. If you add water, what happens? Complete ionized, no? If you add water here, what happens? Partial ionization takes place, isn't it? Partial ionization takes place, correct or not? Understood? But when it becomes completely ionized, we don't know. What? At infinite dilution, at one stage, if you add more water, if you add 1 liter of water, it will ionized. If you add 1 liter of water, same thing means it will not ionized. But it will take 2 liters. When we don't know, 2 liters, 3 liters, 4 liters. Okay. When it becomes ionized, still we should add some water. So we should add more amount of water. That at that time we are finding conductivity is called what? Limiting molar conductivity. Understood? Are you following? Okay. That's the main difference between this and this. Okay. But based upon they are giving one formula, that is alpha is equal to lambda m by, that's right. This is one relationship. That's right. Lambda m by lambda m naught. Due to partial dissociation, then only how much dissociation taking place. So alpha is called degree of dissociation. Lambda is called molar conductivity. Lambda m naught what? Limiting molar conductivity. So they will give, any 2 terms they will give. You can find other one, simple one. Okay. Okay. Then written. Then based upon we have one more statement, Oswald dilution law. You know that? Oswald dilution law. Everything based on only weak electrolyte, because strong electrolyte completely ionized. Don't worry about that. But they are all focusing only on weak electrolyte. Okay. So then only they are making so many statements. So Oswald dilution law also, why they are creating means based upon only weak electrolyte. Okay. You know that here. What's the formula for that? So many formula is there. No derivation here, only formula. K is equal to alpha square C by 1 minus alpha. This one formula. Alpha is called, what is alpha? Degree of dissociation. Understood? C in a concentration, K in a dissociation constant. This is called what? Dissociation constant. Okay. Alpha na degree of dissociation, K na dissociation constant. Okay, dissociation constant. C na concentration, you know that. C in concentration. Okay, so all this formula keep in mind. Then, only one statement will complete. Faraday first law, second law. Faraday first law, also very important. First law means Faraday's first law of electrolysis. What is what is meaning for electrolysis? When you pass electric current, electrolyte is completely dissociated into ions. Okay, but when we add water, the electrolyte completely dissociated into ions, but it will be deposited at cathode and anode. No, so then only when you decomposition of electrolyte by passing electric current is called electrolysis. Okay, so Faraday first law tells about, just remember, M proportional to Q. That's all. Simple. Q is called quantity of electricity. M is called mass of the substance deposited at electrode. If you pass more amount of electric current, the mass of the substance deposited at electrode also increases. Understood? How much current, how much time you are spending for study, so you will be getting more marks like that. Okay. If you spend more marks, spend more, score more. You know that. So when you study in 12th standard, teachers are always telling like that. If you spend sometimes more time with your textbook, you can score more. Okay, we have one guide is there. Score more, one guide. Okay, but that guide is coming or not, I don't know clearly. Okay, 10 years back, okay, that guide is the score more for chemistry. Okay, so I'm usually telling, okay, buying score more guide is not important. You have to spending some time with that guide, then only you can get more marks. Okay. Likewise here, if you pass more electric current, the substance deposited at electrode also increases. M proportional to Q, just keep in mind. That's all, simple. One constant, no? You put one constant, no? Z, Q. Z is called electrochemical equivalent. Z, Q, what is Q? Study in physics, no? Passing 1 ampere current for 1 second. Q is IT. You study, no? This is the formula. Just keep in mind. Right, this formula. Z is called electrochemical equivalent. Formula is, it is one small formula. Equivalent mass by 96495 coulomb or 500 coulomb. No problem. Not for, sometimes 487 is given. Okay, I simply put 500. Okay. Then equal mass also one formula. What's equal mass? Atomic mass by number of electron for reduction. That's the formula. Understood? Understood? Simple. You write one question. Simple question. Suppose here, in copper sulfate solution, how copper will be? We have copper solution. Copper, how the copper ion? Copper, so 2 plus. That's important. In copper sulfate solution, copper in the form of? Cut off. In AgNO3 solution, Ag in the form of Ag plus, no? Balance Ag plus NO3 minus. Cut or not? In nickel chloride solution, nickel in the form of? You must know this one. Understood? Okay. So, it gets 2 electron, it becomes what? It gets 2 electrons, then only it becomes copper, no? Okay, copper is deposited. How much copper is deposited? That's a question. Okay. we are passing current I is equal to 1.5 ampere. Okay, they are asking to find out the mass. Just write fast. It's a question. The last page, the cells and all is given. No, it's primary cells, secondary cells. That's not fully theoretical part. Primary cell means, use and throw only. So once use means after that, if there is no chemicals in the cell means no reaction takes place. So no current is obtained. We cannot able to reuse or recharge once again. But secondary means we can able to recharge, reuse. Okay. So here in this that one you just memorize which one acts as a cathode, which one acts as an anode, which is electrolyte, what reaction takes place, anode reaction, cathode reaction, uses. This only just you make a notes and prepare last part. Okay. Right. What's the formula? Last sum. Are you going to complete? Atomic mass is given. Write one more thing. All this information, right? Atomic mass is given. Atomic mass of what's the formula? M is equal to ZIT. ZIT. Z is what? Equal mass by 96500. Okay. Now, equal mass? Atomic mass by? Understood. Z is equal to, atomic mass by number of electrons for reduction. So, atomic mass by 2. Actually, copper sulfate, copper in the form of C2 plus 2 electron. So, how many electron for reduction? 2. Okay, that 2 here. Understood? Okay. Now, by 2. I is what? 1.5. Though, mostly, time in seconds. So, what? 600 seconds. Understood? Put 600, that's all. If you solve this, okay. Right fast. This kind of sums they'll give mostly. M is equal to ZIT, that's a formula, keep in mind. Okay. M is equal to ZIT. Simplify. Okay. You know how to simplify. You can do it later. This is a method to do. Okay. Just copy them. Everything just copy them. Do it later. This only you must know. Suppose AgNO3 means what? By? Suppose AgNO3 solution means by what? By 1. Ag plus, yeah. Ag plus you put only 1. Silver is, silver 108. Atomic mass. So 108 by 1. Understood? Are you following? Okay, right. Understood? The last one. Faraday's second law. It's not statement, Faraday's second law is Faraday's second law. Law of electrolysis. So, the only statement they'll ask here, statement means, see, simple one. Listen, suppose I am taking 3 different electrolyte, not 3 or 4, we can take whatever it may be. I am taking 3 different electrolyte. In this electrolyte, in this vessel I am taking sodium chloride, in this vessel I am taking copper sulfate, in this vessel I am taking aluminum chloride. Okay, connect all this. Okay, by we have electrode will be there. Okay, okay. Now we are passing same current 1 Faraday through everyone. Okay, 1 Faraday. So see what they are telling means, when you pass same quantity of electricity through different electrolyte, after that they check how much ions are deposited. See, it will be like this, what? Na plus Al3 plus cut off. It will be like this. It's an electrolyte. Yeah. When you pass same amount, same quantity of electricity through different electrolyte, how much sodium is deposited? So sodium gets 1 electron, it becomes what? Sodium. Cut or not? Copper 2 plus gets how many electron? 2. Then only it becomes what? 1 mole of copper deposited. Aluminum ion, it needs what? 3 electron. Then only Al is deposited. Okay. See, when you pass same current quantity of electricity through different electrolyte, after that we have checked the mass of the substance deposited electrode depends upon its equivalent weight. The equivalent weight will be different. Even though we are passing same quantity of electricity, but amount of substance deposited at electrode will be different. Teacher is same, NEET examination is same, subject is same. Okay, getting marks will be different. That's the best example. Okay, we are taking different electrolyte, passing same current, but substance deposit at electrode will be differ, because it is sodium ion, a copper ion, aluminum ion, all are different. No, okay. So they are saying it depends upon only equivalent weight. Okay, how much substance are depositing depends upon equivalent. See, simply they are saying this one. See, 1 electron means 1 Faraday. Just keep in mind. 2 electron means what? 2 Faraday is necessary. For 1 mole of copper is deposited, 2 Faraday is necessary. Very important one. 3 Faraday is necessary. Okay, this one right, all of it right. Say 1 Faraday means how many coulomb? 96. Kata. 2 into kata. 3 into coulomb. Suppose they will ask Faraday, or sometimes they will ask coulomb. Coulomb means this answer. Understand? Right fast. This one is just right. Important. Last question, only one question, right? That's all. I'm going to stop. Find Faraday Cr 2072 minus plus 14H plus 6 electron gives 2Cr3 plus 7H2O. Find Faraday. Everything they will give. Don't worry about what is this. 6 electron means what? 6 Faraday. Simple. Okay, 6 electron means 6 Faraday is necessary. Then only 1 mole of dichromate is reduced. It will be reduced. No. 1 Faraday. 6 Faraday is necessary. We need 6 Faraday. Okay. Write all this. M104 minus. Tomorrow I am going to take this lesson, problem solving session. Go through today. Then only when I take tomorrow problem solving sessions, I am going to give 7 sums in the same chapter, I think, tomorrow. Today I given already the questions. Okay. First you go through the topic, simple one. Here, it's already told you in DNA block elements. Isn't it correct or not? How many? 8 H plus, I think. Yeah. 5 electron gives M12 plus 4 H2O. Correct? So how much required? 5. Okay. 5 Faraday is required to reduce M104 becomes Mn 2 plus. So 5 Farad is the answer. Understood? Last question, only one question. Find Faraday for 1 mole of Al2O3, 1 mole of Al. 1 mole of Al from Al2O3. Tell me correctly. Right first. Find Faraday for 1 mole of Al from Al2O3. I am telling no. Aluminum chloride, aluminum in the form of Al3 plus. Likewise, Al2O3, Al in the form of Al3 plus, Al3 plus only. Understood? Al3 plus only. So, Al3 plus no. Okay. 3 electron. Then it becomes what? 1 mole no. 1 mole. They are asking 1 mole. In this compound, Al in the form of Al3 plus ion. So it gets 3 electron, then only it becomes what? Al. So what's the answer? How much Farad is required? 3 Farad is required. That's all. Okay. Here I given clearly electron. But this is somewhat different one. Okay. Right. That's all. These are all basic about electrochemistry. Nearly I touch all the topics mostly. Okay, understood. Right. Sure. Okay, I stop up to this. Okay. Next class I'll start the new lesson. I think mostly organic chemistry, aldehydes, ketone, that chapter I think. Okay. Okay, students. Bye.